Good morning, students. Today we are going to discuss little advanced topic of trigonometric functions like the domain ranges of trigonometric functions and their graphical representation. So here we are going to discuss about these trigonometric functions from the properties of function point of view. What does it mean? For example, sin x. What is its graphical representation? What are all the values that x can take? Right? The moment I write y equal to sin x, x is the parameter. X is the parameter of the function sine and y is the value as returned by the sin x. Now, what will be the value of x? What all values of x it can take and what all values it can return, right? So if I think about like this, that y equal to sin x, we are going to discuss that what all values that x can take, right? That is called the domain of the function sine, and what all values it can return, that is y, that is called the range of the function sine. I hope you have clear understanding about domain and ranges of a function. If not, please have a look into my previous lecture on the domain, codomain, ranges of function. Okay, so you need to look into the set, relations and function, that topic. Okay, thank you. Sorry. Now, today we are going to discuss this one and its graphical representation. How the curve looks like y equal to sin x. Like that, we will discuss about cos, tan, cosec, sec and cot as well. Thank you. So, one thing I would like to mention here is that x we will measure in radian. Okay, radian is nothing but the real numbers, and that we will measure along the x-axis, and the value of the function will measure along y-axis, right? So if we take this as 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi and so on. Right. So these are the angles measured in radian. So this is the x-axis, positive direction of x-axis from here to in this direction. So this is the negative x-axis, negative direction of x-axis. So here I will get minus pi by 2. It is minus pi minus 3 pi by 2 minus 2 pi. And along y-axis we will measure the value of this function. Okay, so this will be, this is 1, this is 2, and in that way it will continue. And here this is minus 1, this is minus 2, and in that way it will continue along the negative direction of y-axis. Now the sine looks like this. We all know what is the value of sine 0? It is 0. So sine function looks like this. So let me write it very clearly like this. This is the sine curve. Look it very carefully. So sine 0 is 0. Then it is increasing function till pi by 2. Till pi by 2 it is increasing. So this is pi by 2. And the maximum value in that pi by 2 is 1. Because sine 90 degree, that is sine pi by 2 is 1. Good. So now after pi by 2 it starts decreasing till pi. Not till pi. After that also it is decreasing. So it is in pi, it is again getting the value 0. Sine pi is 0. Then again it is decreasing till 3 pi by 2. Okay. After 3 pi by 2 it starts increasing. And in 2 pi it again becomes 0. In the negative angle, in the similar fashion, what we see is that it is decreasing from 0 and it attains the maximum, means that is a negative value, that is -1. So here it is -1. And then after that it starts increasing. In the minus pi it attains the value 0 and started increasing, and in 3 pi by 2 it is getting the maximum value of 1, that is the value of 1, and again it started decreasing. So this is the maximum value and this is the minimum value. So here also this is the maximum value. So what we see, what is the domain of this function sine? Domain is, it can take any value, that is from -infinite to +infinite. That is the domain of sine. And what is the range? Range is that what are the values it can return, the sine function. It can return any value between -1 to +1. You cannot find a value returned by sine which is more than 1, okay, more than 1 or less than -1. Right? So it will be always between -1 to +1. So what we observed is that in case of the function sine, okay, the domain is actually minus, that is the set of real numbers R, which is also known as -infinite to +infinite. That is -infinite to +infinite. And what is the range? A range is the function, it is the -1 to +1. That is a closed interval. I hope you have a clear understanding about the closed interval and open interval. If not, let me give a quick recap. Suppose I have two real numbers. One real number here is A and another real number here is B. Then any value between A and B, okay, we are assuming that B is greater than A. The assumption is that B is greater than A. Any value between A and B, including A and B, both the values, is called a closed interval. So X belongs to the closed interval is denoted by the square bracket. This implies that A less than equal to X less than equal to B. Right. So including the value A and B. Now if I tell the other way that Y belongs to the open interval A and B, that means is that any value between A and B excluding A and B, A and B should not be included in the open interval. So this implies A less than Y less than B. Please have a note, is that less than equal to less than here. Correct? Okay. So what we see that the domain of sine is the set of real numbers, that is -infinite to +infinite, and that I mentioned in open interval because from a theoretical point of view we really cannot reach -infinite or +infinite. You can approach towards it. That's why it is open interval, and range is -1 to +1, including -1 and +1. That is why it is the closed interval -1 to +1. Correct? Now let's see what is the graphical representation of cosec x, which is the reciprocal of sin x. Let's see. So this is the positive direction of x-axis, this is negative direction of x-axis, this is negative direction, this is positive direction. This is the positive direction of y-axis, this is the negative direction of y-axis. Now as we mentioned that we will measure the angles along the x-axis. So this is pi by 2, or this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, and continue. Here it is minus pi by 2, here it is minus pi, here it is minus 3 pi by 2, here it is minus 2 pi, and continue. And the values here are 1, 2, and it continues like this. And here the values are minus 1, minus 2, and it continues like this in this direction. Now let's see what will be the graphical representation of cosec x. We know from a theoretical point of view, we know cosec x equal to 1 by sin x, the reciprocal. So we see that it will be flipped around this point, flipped around the point 1. So that means it will be like this here, but 1 point. What is the value of sine 0 is 0. So what is the value of cosec 0 is undefined, 1 by 0. Similarly, what is the value of sine pi is 0, but what is the value of cosec pi is 1 by 0, which is undefined. So we really cannot reach to this point 0 or pi when we draw the graphical representation of cosec x. So what it looks like? It will look like fine. So this is the point pi. This is the point pi, and this is the value 1. Okay. So what we can say is that you see one thing, that this cosec x cannot reach or cannot touch very specifically to say that y-axis here, that is the 0. Similarly, it cannot touch the line which is the pi. What is the equation of this line from a trigonometry? That is x equal to pi, right? So it cannot touch that line pi. Clear? So what we say is that it can, so the function will be like this very specifically. So it will go like this. It will never touch these two lines. Sorry, extremely sorry. It cannot touch these two lines. So this is known as, called asymptotes. Okay, asymptote is something where a curve, a line and a curve touch at infinite. Then it's called an asymptote. These lines are asymptotes. Okay. So anyway, so this is the asymptote is the topic of trigonometry that we'll discuss later. But here what I am going to say is that the graphical representation cosec x between 0 to pi, it cannot touch the point 0. It cannot touch the point pi. In a similar manner, if you flip this one between pi to pi by 2, so along this line it will be like this. So this is pi and pi to 2 pi. I'm sorry. If you see the representation from pi to 2 pi, it will be flipped around this point 3 pi by 2 in this manner. So it will be like this. So if we draw it here, how it will be? So pi by 2, we will draw the line. This line we will draw first, and this line is there, then it will be like this. So this is a -1 value, okay. Okay, and this is the value -1. Okay, -1 is the maximum value. Here also it cannot touch that value, touch the points pi and 2 pi. Similarly, in the same fashion, between 0 to -pi, how we can draw 0 to -pi? If we draw this line -pi like this, and between 0 to -pi, it will be alright. Again, between -pi to -2 pi, this is -2 pi. So like this, and this is the value 1. This is the value 1. Again, it will never touch whatever I draw in red color. It cannot touch -2 pi or -pi. So this is the representation of cosec pi. Correct. So what we see, what is the domain and range of the function cosec? So this is cosec. Okay. So what is the domain? Domain is anything in the sense, in a real number, except these points 0, pi, then 2 pi, -pi, -2 pi, like this. So that means it is actually the set of real numbers except the multiple of pi's, right? So that means the domain is the set of real number difference n into pi, right? So that is the domain. N is actually any integer, correct? And what is the range? Range, if you see, what is range? Just a quick recap. Range is what all values that function can return. Okay, so we see that the cosec function can return anything beyond except -1 to +1. Apart from -1 to +1, it can return any value. You will never find this red color drawn that curve is anywhere crossing between -1 to +1. It is never crossing anywhere here. But below -1, it is covering everything, right? And above +1, it is covering everything. So range should be that -infinite to -1, then 1 to +infinite. That is infinite. So how we can represent in the form of set? Here it is. It is -infinite, that is open interval, to -1, that is closed interval. Union is 1 to infinite. Clear? Alright. So, fine. So, in case of any doubt about that, it is called semi-closed interval. One end is closed, one end is open. So that means what? If I take another point, Z belongs to, if I say it is A, open interval A, but at B it is closed. That means what? That means A less than Z less than equal to B. If I take another value T belongs to, here it is the closed interval and here it is open interval. That implies a less than equal to t less than b. Correct? So far we have discussed about the graphical representation of sine and cosec, and we see what is the domain and range of these two functions, sine and cosec. Correct? So please have a look into it for a couple of minutes. After that we are going to discuss about the graphical representation of cos and sec, followed by tan and cot. Thank you.